Okay, so in this recorded lecture, I'll discuss on the eigenvalue analysis, no, of a truss structure. We'll be using the same formula as we did sa beam. From this equation, this is an eigenvalue problem. We need the stiffness matrix. This is the stiffness matrix. And this one is the mass matrix. Yan. And so we need these two matrices, no, in order to solve the natural frequency. Yeah. Okay. We already have our function using SMAT, no, to do an eigenvalue analysis, no. So we'll just input this stiffness and mass matrix. Okay. So I have here a sample problem from Mario Paz. Okay. And so this is just a three-member truss structure. Okay. So I'll copy that here. Number one, two, yeah, okay. Yeah, so this is the truss problem. And this length is 60 inch. Horizontal and 60 inches vertical. And area is equal to 10-inch square, while elasticity is 30 times 10 raised to 6 pound per inch square, while the unit mass 0.1 pound second square per inch square. So naka-English unit siya. Okay. So let's decide, no, how do we assemble the stiffness matrix. So I'll decide this is member 1, for example. This is member 2. This is member 3. So gaya na ginagawa natin sa stiffness matrix. So for example, K1, ano muna yung degree of freedom numbers pala niya, no? So let me say this is degree of freedom 1, and then 2, then this is 3, this is 4, this is 5, this is 6. Okay. So for the K1, ang code niya is 1, 2, 3, 4, of course, no? So 1, 2, 3, 4. For K2, anong code niya? 1, 2, 5, 6. Okay? 1, 2, 5, 6. And for K3, so code niya ay 3, 4, 5, 6. Right? So this is member 3. Now 3, 4, 5, 6. Now, what will be our S matrix or yung stiffness matrix natin? So how many displacements do we have? Since roller support to, so that's one displacement already, no? So capable to move sideways yung ano, no? In this point, yung thrust natin, and here also dalawa. So that will be 3 in total. Okay, so tatlo. So ang code nun is corresponding to those degree of freedom, no? So that will be degree of freedom 3 and 5 and 6. Okay, so 3, 5, 6. So that will be 3, 5, 6. Okay, so our S matrix or our K is 3 by 3. Okay, so 3, 5, 6. So if you were going to extract, no? So here, itong dalawa. And then here, this one. So yeah, yung mga content niyan. So let's say this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. No? So meaning, yung mga values niyan mapupunta dyan. Okay? So, hindi ko na explain further kung paano yan. It should be, ano, no? I should already know this from advanced structural analysis, no? And anyway, we have our SMAT code to perform or to generate our stiffness matrix. Although, since 3 members lang to, kaya pa rin to manually gawin, no? Sa Excel. Okay, so in that, so after that, so you can now get this K matrix. Okay, so that's the stiffness matrix or the S matrix ng ating truss structure. So next is the mass matrix. So same logic, however, I need to show you the the stiffness matrix and the mass matrix. So this will be our stiffness matrix, by the way, no? For the truss structure. No? So global stiffness niya. Dito na siya. Yan. So in-encode ko na siya dito. I will also give you this SMAT file, no? If you want. Yan. So dito na siya. In-encode ko na siya dyan. Okay. EA over L. Okay. And then cosine square theta, cosine sine, negative cosine square, okay, cosine theta, sine theta. Okay? How about the mass matrix? So according kay Mario Paz, ito naman yung equation niya ng mass matrix. Where's that? This one. Yan. So this is the equation for the mass matrix. This is ml over 6. So in-encode ko na rin siya dito. Yan. Yan. ml over 6. Then so ml over 6. And then we have yung ito. Yung 2, 2, 2 na diagonal. And then 1. Okay? So, yan. So, the mass matrix per member. So, makita nyo meron tayo ano dito, transformation matrix. Because this is the the mass matrix in the local axis, no? but you should transform this to global axis. So parang sa sa stiffness, to get the global stiffness, you use this formula. T transpose K local times the transformation matrix. So ganun din sa mass matrix. So let's say this is the global mass matrix, T transpose, then the local mass matrix times the transformation matrix. The same logic. Okay? Kaya meron tayong transformation matrix dyan. And what's the transformation matrix? Ito naman yun. Okay? It's basically function of cosine and sine of the angle of inclination. Okay? So, and that's it. So once you have okay, so and so here's the problem again. Ito. Yan. So ito yung transformation matrix. Okay. What's the problem? Ito, no? So may kita nyo kay Mario Paz kasi pinakita pa niya yung local stiffness matrix. Ako hindi na no? Dumiretso na sa global stiffness matrix. Anyway, so with this SMAT code, no, napakita ko naman na to sa beam, no? So this will be the code for obtaining the stiffness matrix, which is S4, yun yung designation ko. Then for the mass matrix, ito naman, ayan. Of course, you will look for 3 members. Okay? So that's it. Upon input mo rin of course yung mga theta. For example, yung theta ng member 1 is 0 of course. Let's see kung consistent. Ayan. Ayan, 0. Kasi naka-horizontal naman siya. Member 2 is since it's vertical, so that's 90 degree. That's pi over 2. And then si member 3 is 2.356195 derived from kasi 60-60, so therefore this is this is 45 degree. Yan, 45 degree yan. So therefore this is 135, no? 135 degree. If you convert that to radian, so 135 times pi over 180, you should get 2.356 radian. Kasi naka-radian si SMAT, no? Okay. Yan. So length 60, member 1, 60, member 2, hypotenuse 84.8528, member 3. And area as given here is 10 inch square. Elasticity 30 times 10 raised to 6. And the unit mass 0.1. So basically na-encode ko na lahat ng given. And about the yung BU matrix pala natin, no? One of the critical requirements dito sa code ko, yung BU and BB matrix, because so the address, no? So for member 1, ang kinuha natin is code 3, no? Si code 3, which is pangatlo, no? So pangatlo siya. So that is 3. Okay, how about sa member 2? We'll extracted 5 and 6, no? Which is third and fourth, no? Pangatlo and pang-apat, no? It's third and fourth. So that's why our BU for member 2 is 3 and 4 here. Okay? And for member 3, we extracted the first, the third, and the fourth. No? So the first, the third, and the fourth. Okay? That's why it's 1, 3, 4. 3, 4, 1, 3, 4. Okay? Next, the BB matrix. So what's the destination? So the destination of 3 to our S matrix is first, no? Una siya. So that is 1. The destination of 5 and 6 is of course second and third. That's sa ating S matrix. Second and third. And finally, 3, 5, 6, its destination is 1, 2, 3. First, second, and third. Okay? So that's how you encode the BU and BB matrix. And that's it. Using this code. Yeah. So this is my K matrix. So this is now our K matrix, and this is now the mass matrix. Okay. Then I need to compute this. Basically, this is M inverse times K. No? And pag na-compute mo na siya, okay, using the function that we've been using since MDOF problem, yan, it will give you now the, um, the omega square and the eigenvector, the mode shape. Okay. So since omega square to, I copy paste this in order to get the square roots, the natural frequency already. Okay? So ito na siya. And then, by the way, no, you need to to make sure that yung looping niya is consistent dito. Since we have 3 degree of freedom, so this will also be looped into 3. Yeah. So, then, let me check. This is 1. So, this is 3. Yeah. So, this is now our period, modal period. Okay? 0.016. And 381, 1476, 1115. So again, the whole process no is already familiar na kayo, no? Ang bago lang here is the stiffness matrix for the truss member and of course yung mass matrix. No? The rest is supposedly you already know, no? During the beam eigenvalue problem. By the way, no, let's verify that. Okay, Mario pass. What did Mario pass gets? Ayan. So, ito yung nakuha ni Mario pass. I think may content discrepancy. So, 415 against 381. 1,034 against ito, 1,000, ano to? 115, no? And then 1,526 against 1,476. Anyway, if you convert that into period, halos ganito pa rin yan, no? For example, itong 415, 2 pi over 415. So I'm getting 0.015, diba? So halos hindi nagkakalang. So we got 0.016. No? How about yung 1034? Yan, 0.006. Okay? Okay. So that's it. So now let's try using stat. Yan. So this is the SMAP code for that. Okay. Now let's now try another Truss problem. Example, we have this kind of truss. Yeah, so truss structure, for example, huh. So gawin na lang natin itong ano, no? Equal yung dimension para madali sa SMAT. So I made this, say, ano ba, 2 meters. No? Gawin natin itong 2 meters, also 2 meters. Yan. Also, this is also 2 meters. Yeah. Yan. Kasi meron akong ginawang ganyang model. Babaguhin ko lang yun. Yung geometry. Yeah. So, this is an old truss structure. So, lagay ko siyang 2 meters, yung X. Save natin. Oh, existing number. So, 5. So, since we have ito, 2, 2, 2. No, yun lang naman, ano? 2, 2, 2. So, this will be 2 meters. Ayan. And this is also 2. This is also 2. So, this is, yeah, 2. Okay. Yan, okay na to. 2 meters. This is also 2 meters. Okay. Now let's designate ano, member numbering. No? Say this is member 1, member 2, member 3, member 4, number 5, 6, 7, 8. Okay. Then degree of freedom numbers. Okay ko na lang. Bilisan ko na lang. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we have 8 members. Okay. For example, in K1, that will be 1, 2, 3, 4. K2 will be 1, 2, 7, 8. K3, 5, 6, 7, 8. K4, 3, 4, 7, 8. K5, 3, 4, 9, 10. 3, 4, 9, 10. K6, medyo madami na, no? K6 will be 7, 8, 9, 10. Ito yun, no? 7, 8, 9, 10. K7, 7, 8, 11, 12. And lastly, K8 is 9, 10, 11, 12. Yan, medyo madami na, no? But ano yung degree of freedom numbers natin? No? We have, since naka-restrain tayo dito, so we have 2, 4, 6, 8. No? So ang ating S matrix will be 8 by 8. Ganyan kalaki, no? Yung matrix size. So ano yung code nun? No? Basically ito, 3, 4, 7, 8, 9, 10, 11, 12. Okay? So, gawin ko na lang, bilugan ko na lang dito. No? So, 3, 4, ito, 7, 8, yan. 9, 7, 8 ulit, no? Here. 7, 8, again. 3, 4, 9, 10 is kasama na sila lahat. Ito. Kasi we are, maximize ko muna. Yan, 3, 4, 9, 10. 9, 10 here. Ay, sorry. 7, 8, 9, 10 pala. So, lahat ulit. I-extract natin dito. 7, 8, 11, 12 also. 9, 10, 11, 12. Okay? Kindly take a look dun sa mga binilugan natin. No? Meaning, yan yung mga i-extract natin na data from each stiffness matrices in order to yan, to generate our structure, stiffness matrix. Lahat yan, no? Okay? So, ginawan ko na yan ng SMAT code. Although, hindi pa correct yung, yung yung mga length. I think ito yun. So, update natin to. So, file, save as. Gawin ko itong dahil na 6 na to. Save. Yeah. Yeah. So, member 1, for example, what's the length or what's the theta of member 1? 90 degree, no? So, pi over 2. Okay. What's the angle of member 2? 45 degree yan. So, that's pi over 4. Okay. Member 3, yeah, pi over 2. Member 4, 0. Member 5, again, pi over 2. Member 6 is negative pi over 4 kasi ganyan siya. No? Member 7, pi over 2 again. And then, member 8, 0. Okay? Now, I'll update the length. No? Kasi 2 meters na sila. No? So, this will be 2. Lahat naman, 2. Except yung diagonal. No? This is 2. Then, for the diagonal, ano na yung length ng diagonal? 2 square plus 2 square. Square root of that, 2.828. It is 2.828. Okay. Next, what about the area? So, ito na yung ano niyan. Properties. So, I assumed a 0.05 meter diameter na steel. So, if you compute for the area of that, area is equal to 0.05 d square over 4. Pi d square over 4. You will get 0.00196, no? Meters square. Kaya dito sa SMAT, 0.00196. Okay? Elasticity, 205 times 10 raised to 9. And then yung unit mass, no? Ito na-compute, kinumpute to because the unit mass is basically the raw, no? Times the area. No? It turns out, if you convert the raw of steel in STAAD, ito si steel, yan, 76.8195. Convert that to kilogram per cubic meter. That is 7830.73 kilogram per cubic meter. So multiplied sa area, which is 0.00196 meters square. You will get 15.348, which is naman, pretty much the same. 10.375. Anyway. May discrepancy lang doon sa rounding off ko. Okay, so M, E, yan, same formula, loop to 8 members. Mass matrix, loop to 8 members. And for the BU and BB matrix, so quickly, let's just show, for example, si member 1, ito, kita ba? Yan. Number 1, ang in-extract natin is 3 and 4. Ito yan. Okay? Okay, member 2, ang in-extract natin is 3rd and 4th. Member 3 also, 3rd and 4th. Member 4, 3rd and 4th. 3, 4, 7, 8. Lahat pala. Yan. Sorry. 1, 2, 3, 4. Member 5, lahat din. 1, 2, 3, 4. Lahat na, no? 6, 7, 8, 9, 10. Okay? Then, the destination, BB matrix, 3, 4, of course, mauna siya. 1 and 2. Yan. 7, 8 will be 3rd and 4th. Yan. Dahil 7 and 8 din to, 3rd and 4th. Yan. So on and so forth, no? Base yan doon sa numbering mo. So, 3, 4, 7, 8, 9, 10, 11, 12. Okay? Kasi lumalabas yung 11, 12, yun yung pang 7, 8 natin. Okay? Kasi nga, 8 by 8 yung ating S matrix. Okay, so once na settle na tayo dyan, BU and BB matrix. Ayan, so this is the stiffness matrix. Mass matrix. Here. And yeah, so nag-update na si SMAT. We'll copy this and paste here. Yeah, kasi niyo no, kinopya ko pa siya manually because nag-update siya, no? When we update the information, the data. And finally, this is our modal period. Let's focus on the ito. Yung first mode, 0.019. Let's now check that kay stat. Ayan. But before checking kay staan, di ba binago natin yung geometry? Okay. Okay. Self-weight. Kasi self-weight yung in-assume ko. Anyway, let's try to run this. Analysis. Ayan. So, post-processing and dynamics. Yan, may discrepancy when I use self-weight, no? 0.016 versus kay staad na 0.019. Okay? Yan. So, that's the first mode kay staad. Now, what if we get the total length ng truss, for example, let's get the total length nito, and then apply dito sa joint, no? Let's check, no, what will be the discrepancy naman, no? So for example, yan. So ano ba yung total length nito? So we have how many twos? So we have 1, 2, 3, 4, 5, 6. So 6 times 2 is already 12. So length is 12 plus dalawang diagonal. Is the length of the diagonal. 2.828. 2 so that will be plus 12. 17.656. Yeah. So, that's the total length. Tapos may area ka na ito, 0.00196. Then, meron kang unit or density na 7830. So, let's just try to total, to, to find the total weight. 7830.734 times 0.00196. Ayan. 15 point ano, kilogram per meter times the length, 17.656 meters. So that will be 270.988 kilogram or 2.66 kilonewton. Okay? So if I divide it by 4, since 4 joints yan, yun natin, dito, doon natin i-distribute, no? For example. Then symmetrical din naman yung truss. No? Ito, yan, dyan natin natin. So that will be 2.66 divided 4 is 0.665. Yan. Tapos, i-comment ko tong self-weight. So, yan na yung this mass applied at the joint. So, one way of, of lumping the masses, no? Sa joint naman. Yan. So, let's try to solve. Done. And dynamics. Yan. So, nakita nyo, the period is now almost the same na sa nakuha natin. 0.019. Okay? So, that's it, no? So, again, the process is still the same sa build, no? Except that we're just getting the stiffness matrix and the mass matrix, no? Yun naman nagbago. And then just use the function that we're using. And then you can get now they call this the natural frequency of the truss. So, sa star, ito siya. View, mode 1.